Okay, so welcome to our project presentation for this silent traffic lights project for the subject of nervous systems at protype, and it is a fossil logic project. So a little bit about the context. Noise pollution has become a health problem at cities. So with this project, we pretend to reduce noise pollution, developing a traffic light system that punish noise and allows to the reduction of noise. Okay, we came up with this news that a system like this was implemented in India and has reduced the decibels of noise pollution. Okay, as a requirement of the project, we have two inputs. So we went for the first input to be the number of cars, and the second be this noise intensity. And the resulting output would be the waiting time for the red light. This is our proposal of our inference system. Okay, the materials we used was an Arduino Uno, push buttons, a KY037 sound detection sensor, and a buzzer that I can explain how we use it in a second. Okay, FIS Design. As I said, this is the MATLAB toolbox designer. We got the first input is amount of cars, the second is the noise, and the resulting is the time of the red light in seconds. Okay, explain a bit the memory functions. Here is the memory functions, the memory function for the number of cars. Okay, so we have three functions, three trapezoid functions. When we represent not many cars, this is a rather few amount of cars, little amount of cars. Sorry, we have an average amount of cars and a lot of cars. Then below this, we got the memory function for the noise intensity. We got where it's a bit of silence. We have an average of moderate intensity of noise, and when it got really noisy. And the output is this time in seconds for the red light. Okay, in the less seconds we got is faster. If we got more waiting time, we got a normal waiting time range, and when we got and it is slow when our range is bigger. Okay, so these are inference table. There's not a lot to see here, but one thing you have to understand, this is our proposal, and between the more noise there is and more cars there are, the resulting waiting time is slow. This means we have larger, bigger waiting times for the red light. So the silent between less cars and less noise, it is faster. This means we have rather slow waiting times for a red light. And these are our inference rules that again is not worth to go into depth of them. Okay, so here is our working prototype. Okay, I can explain what is in here. Okay, here we have three push buttons that represents the three ranges, the three memory functions of the noise intensity. We have one for where there is a little sound, moderate, and when it gets noisy. And these are three push buttons are representing the amount of cars. So we have when there are few cars, when we have an average cars, amount of cars, and we have too many cars. Okay, and these values are right into the Arduino. Okay, these three push buttons for intensity control the buzzer, and the sound is being sensed by the KY037 sensor. Okay, and here we got the outputs that are representing three LEDs by three LEDs are representing the traffic lights sequence. Okay, and this all is controlled by Arduino Uno that is connected into MATLAB. So it's worth noting that we didn't make use of any Arduino code. All is used by MATLAB Arduino interface that we have make use of. Okay, so the first the program starts, and it has like a cycle of an even loop of say turns. So in the first turn, a sound is being read. Then it goes to a red light, and we see that the result was it read 17 cards with a noise of 70.7220 intensity, and then the resulting output was 7.6002 seconds for the red light. And this goes all the way back into Arduino to being in the red. Okay, so this is another turn. It reads 8 cards, an intensity of 5.207786, and the resulting waiting time is 4.7947 seconds. And this again is represented to the traffic lights in the Arduino. And this other example is when we got 2 cars and intensity of 3.5044, and the response waiting time is of 2.5004 seconds. Okay, these were 3 examples that we're going to see more in depth here. Okay, in the example here, we got a level of noise of 5 and 2 cars, and the resulting time is of 4.444 seconds, and is very similar to the second case that you saw in the video. So here we got 13 cards that represents a certain amount of too many cars, and a noise of 13 that represents too much noise, and we have 7.94 seconds that is similar to the first example in the video. So in this another example, we have again too many cars, but rather a bit of silence of 2, and we got 5.5 seconds that represents the third, is very similar to the third case in the video. Okay, these are the generated surfaces, but for the design toolbox. Okay, and it's worth notice that we actually developed the algorithm here, and you can see in this GitHub repository, and you can contribute also to the project and see how we implement. This is the toolbox designer, and we also have the algorithm for the Mandani fuzzy inference system. So this has been all for the video. Thank you again.